We're attempting to model the height of a slide as a function of its horizontal distance from the stairs. So that means our output is height of the slide, and our input is the horizontal distance. So I'll call this D for distance, and I'll call this H for height. So H and D. And this is measured in feet. So I'll put feet here, and I'll put feet here. What we do know is that the slide spans 100 feet horizontally. So from the from the stairs, if you walked over basically beside the slide itself, you'd walk over 100 feet before the slide ends. When you walk from the bottom of the stairs of the slide to the middle of the slide, its height is 60 feet. So if I walk over to the middle of the slide, which is 50 feet, because that's halfway between 0 and 100, then I get a height of 60 feet. When you walk a total of 100 feet, the height of the slide is at ground level, 0 feet. So that means it's at 0 feet right there. Okay, well, we know that in this case, the rate of change, since it's change in output over change in input, the slide drops 60, I'll call this vertical feet, we'll call it V feet, for 50, or an increase of 50 horizontal feet. So that means negative 60 divided by 50 will give us a drop of 1.2 vertical feet per horizontal foot. So every horizontal foot that you walk over, you get a drop of just a little more than 1 foot vertically. So it's a pretty steep slide. Okay, well now we need to figure out, because we're going to be modeling. Oh, sorry. So the rate of change we've interpreted. That's letter A. In part B, we're going to create a linear function that models the height of the slide as a function of horizontal distance. Okay. Well, we know that the horizontal distance, the height as a function of horizontal distance, is equal to something, the initial height, how high it is above you when you're standing beside it at the base of the stairs, minus, it drops by 1.2 feet per foot of horizontal distance. So we just need to figure out where it is. Well, if we walk backwards 50 feet, then for every foot that we walked backwards 50 feet, we need to walk up 1.2 feet. So if you go back 50 feet, then that means you need to go up 50 multiples of 1.2. It means you need to increase your height. Well, 50 multiples of 1.2 is going to be 60, and so if you add 60 here, that's going to put you up at 120 feet vertically. So this will be 120. Now if you don't see that, you can think about it this way. You can say height, for a second I'm not going to use function notation, equals initial value minus 1.2d. Now the ordered pair that I have, I can pick a couple of them. I'll just pick 100 and 0 since that one's easy to work with. That means D is 0, or if D is 100, H is 0. And so I plug in, replace what I know, 1.2 times 100, and that gives me 0 equals I minus 120. And I solve for I, so I add 120 to both sides. I get 120 equals I. So okay, I got it that way as well. Here I thought about it graphically. Here I thought about it mathematically. So how tall is the slide? Well, the height of the slide is actually the initial height based on our situation. That we're standing at the stairs, here are the stairs, and it's 120 feet tall.